Hey guys, so today we're going to do a video about graphing a function's inverse, and we're given the original function y equals 3x plus 5, and what we need to know is that inverse function, the inverse graph, graph of the inverse, it can be found by doing a reflection over the line y equals x. And that is a line that goes diagonally across the coordinate system, whatever I should call that thing. Graph of the inverse can be found by reflecting over the line y equals x. And so now let's take a look at our example. I'm going to draw in the line y equals x because that's just what we're going to reflect over, and it'll help you see what we're doing if you know what that line is. So this is y equals x. Let me label that right here. And now we have y equals 3x plus 5. Okay, so I'm going to graph that first. I'm going to start 1, 2, 3, 4, 5. I know it's got a slope of 3, so it's going to be, let's label 1, 2, 3. It's going to go up 3, 1, 2, 3, over 1. I'm going to go down 3, 1, 2, 3, over 1. It's going to continue like that forever, so I can just take a stab at it. Hopefully it's straight enough. It's going to continue like this, and it's going to continue like this. Okay, and now I'm trying to find the inverse. One option is you can actually find the inverse, which, as you know, the process by now is to swap the x's and y's and solve for the new y. So if y equals 3x plus 5, the inverse is x equals 3y plus 5. Okay, now we're going to subtract 5. X minus 5 equals 3y. So then we can say y equals x minus 5 divided by 3. And that's fine, and we could find that function and graph that function. But an easier way exists, and what that is to use these points and just swap their values. So I would make an xy table here, xy, and then we can use the points that we can kind of get really easily, which is the 0 when x is 0, y is 5, because that's our intercept. And then we can say this is for original function, then I'll say inverse function. I'll make another one. And then, well, we use -1 when x is -1. Well, 3 times -1 is -3, plus 5 is 2. Then we can say when x is +1, we've got 3 plus 5 is 8. And that's enough for now. And now we can work on the inverse function. This is one of the unique things about inverse functions, is you can just swap the values. So now whatever is in the y column right here is now going to be in the x column. So now we're going to have 5, 2, 8 for our x values, and then the y values, the x values of the original will now be the y's of the inverse. So now we'll have 0, 5, 0 is a point, 2, -1 is a point, and 8, 1 is a point. If you see that we did there, what we did there, we swapped x's and y's. And now when you graph these points, you'll get an idea of what the graph is doing, hopefully, the shape. So I'm going to graph my point 5, 0, because we're graphing the inverse function now. So 1, 2, 3, 4, 5, went up 0. Okay. Then I've got the point 2, -1, so like 1, 2, -1, we're down there. Then I've got the point all the way at 8, 1, so 1, 2, 3, 4, 5, 6, 7, 8, just fit that in right there, and 1, we'll say is like right there. So now I can see that the shape, it's going like this. So I'm going to connect those lines. My graph is not really drawn to scale. So it's going like that, and then it's going to continue like this. And that is y equals x minus 5 divided by 3. If you look at what we've done, you can reflect this over this line, and that's what you're going to get. It's like a mirror image. So you see that they're holding the exact same point that's on the line because it has no reflection, and that's when they change directions. And I personally like to do it like doing this by setting up a table and then just plotting some points. But you can also do just actually find the inverse function and then find some points using that. So just realize that the line is reflected over the line y equals x, and if you're given the original function, you can always find its inverse pretty easily. So thanks for watching, guys. Hope this was able to help. Let me know what type of videos you want to see, and thanks for watching.